Dear students, today we are going to discuss a very important aspect of organic chemistry, which is about the types of organic reactions. This is a very important tool for the manufacture of so many natural as well as organic products. Organic reactions are a chemical set of chemical reactions which involve purely organic compounds. Organic reactions are used in the construction of new organic molecules as well as the production of chemicals such as drugs, plastics, food additives, fabrics, etc. depend upon a numerous and a large number of organic reactions. Types of organic reactions. There are so many types of organic reactions, but the commonly studied are substitution reactions, elimination, addition, and rearrangement reactions. This slide shows the various types of these reactions with the help of particular example. In the first one, the substitution, you can see the OH group being replaced by chloride ion and water is formed. In addition, a bromine molecule is added across cyclohexene, wherein the double bond gets converted into two single bonds. In elimination reaction, the OH group, when it reacts with a sulfuric acid molecule, it eliminates a molecule of water, resulting in the production of an unsaturation in a cyclohexanol. While as in rearrangement, there is a rearrangement in the substitution as well as elimination and addition as well. Before we explain the types of organic reactions, it's very important to understand about electrophiles and nucleophiles because all the organic reactions revolve around these two particular species. New electrophiles are electron loving species and they are electron deficient, having a positive charge or incomplete octet, which makes them to seek electron rich centers. Example like RCl, Ri, or molecules with C double bond O like RC double bond OR, RC double bond OOR, and RC double bond OCl. Now, nucleophiles are those species which themselves are negatively charged and they get attracted towards a positively charged center. The nucleophiles, they are you can say they are negatively charged species, or they can be neutral as well, but the condition being they should contain a lone pair of electrons with themselves. So, like examples include CH3O negative, that is methoxide, ethyl, cyanide, bromide, etc. While its molecules with neutral are ammonia, phosphine, and dimethyl sulfur, etc. As the name indicates, substitution, it means that something is being replaced by something. So, substitution reactions are those reactions in which a group of atoms get replaced by a new set of atoms. The one which leaves the molecule, they are called as leaving groups, and the molecule which gets attached in the product, they are called as incoming groups, which can be electrophile as well as nucleophile. An example of CCl bond in which the carbon atom usually has a partial positive charge due to the presence of highly electronegative chlorine atoms. Now, what this does is the because of high electronegativity of carbon, the electrons between carbon and chlorine, they get shifted partially towards chlorine, due to which the carbon acquires a partial positive charge and it becomes a center for the nucleophile to get attached to. Now, this slide shows the types of substitution reactions. Nucleophilic substitution, where the incoming group, as I already have told you, is a nucleophile. In this case, you can see that the dinitrochlorobenzene gets converted into dinitrophenol, wherein the chlorine atom or the chloride ion is replaced by OH negative. Since the incoming group is a nucleophile, that's why it is called as nucleophilic substitution. Electrophilic substitution, here the benzene ring is being attacked by an electrophile, a positive charge center, again a substitution. So it can be, the substitution can be unimolecular as well as bimolecular. In unimolecular substitution reactions, nucleophilic, let's talk about. The intermediate is a carbocation which is first formed, and then the incoming electrophile or the nucleophile attacks the carbocation center and we get the substituted product. While as in SN2 reactions, the chlorine or the incoming electrophile and the leaving group, they occur simultaneously, resulting in the formation of a molecule. Now here are some examples of substitution reaction. In the case 1, you can see the green colored bromine is being replaced by Cl negative ion, while as in other case the bromine is being replaced by OH negative ion. In the third one, the OH negative group is replaced by a chloride ion. So all these are the types of substitution reactions. Now what is elimination? Elimination is the removal of adjacent atoms so that we get an unsaturation is produced. This is an example of elimination reaction of alkyl halides. Similarly, it is also like E1 elimination, where the intermediate is the carbocation, and E2 where the elimination occurs simultaneously, that is the bimolecular step. Addition reaction is just the opposite of elimination reaction. Here an adenine or a molecule AB is added across a carbon-carbon multiple bond, resulting in the formation of molecules. So the one here I am showing is the halogenation reaction of ethene, where you get dibromoethane. Second is hydration of ethene, where I am getting ethanol, then as such hydrogenation and then polymerization. Now when we come about rearrangement reactions, this is a special set of reactions which are accompanied by substitution, addition as well as elimination. In the rearrangement reactions, some changes takes place within the molecule and we get a new type of product which we are not expecting, and sometimes same as well, but the sequence of reactions becomes different. Nucleophilic substitution followed by rearrangement. Here it's a simple nucleophilic substitution reaction, but in the first case you can see that OH group gets attached to the bromine group, replaces the bromine group and gets attached at carbon number 2. While as in the second one, there is a shift of hydrogen from carbon number 2 to carbon number 3 as indicated by the blue hydrogen, and the OH group doesn't get attached to that carbon which has bromine, or it doesn't replaces the bromine, rather it replaces the hydrogen ion. Hydrogen, that is called as hydride shift because it forms a more stable carbocation. Similarly, these is a alkene addition reaction followed by rearrangement. Again same, we don't get what we are expecting, so there is a slight shift in the sequence of bond formation and bond breaking. Similarly happens with the elimination reaction, as you can see it. Why we are getting these weird results apart from the normal results? The reason being that sometimes the carbocation which gets generated is not stable. In order to acquire the stability, there is either a hydride ion shift or a methyl group shift. So as such, when the molecule tries to attain a more stable carbocation, there can be rearrangement of groups which brings about this rearrangement, and as such we get a different substituted product. Now, oxidation reduction reactions. These are also one of the very important types of organic reaction. Oxidation means the addition of oxygen or removal of hydrogen, and reduction is the reversal of it, that is, removal of oxygen and addition of hydrogen. Now, how you can identify oxidation and reduction reaction? It can be identified by changes in the number of oxygen atoms at a particular position in the hydrocarbon skeleton, or in the number of bonds between carbon and oxygen at that position. So, increase corresponds to oxidation, decrease to reduction. Similarly, increase in the number of hydrogen in a hydrocarbon is an indicator of reduction reaction. This table shows the oxidation state of carbon in oxygen and nitrogen containing functional groups. See, from alkane we are moving to carbon dioxide. In alkane, the oxidation state of carbon is -4, then in alcohol it becomes -2, carbonyl 0, carboxylic acid +2, and in carbon dioxide +4. So as you go on increasing the number of oxygen atoms, the oxidation state of carbon increases, and we say that the molecule is moving towards an oxidation reaction. The oxidation state of carbon in oxygen and nitrogen functional groups. Here we can see that we have amine, imine and nitrile. In amine, the oxidation state of carbon is -2, whereas in imine it's 0, and in nitrile it's +2. So as we move from left to right, that is from amine to nitrile, there is an increase in the oxidation number of carbon, which is the oxidation reaction, and when we move from right to left, that is, there is a decrease in the oxidation number of carbon, which results in a reduction reaction. So this slide gives an overview of different types of organic reactions. The organic reactions are the backbone of organic chemistry. They are so much indispensable and so much important that without it we cannot make a single product, whether it be used for our daily day-to-day life, or for pharmaceutical industries, or for dye industries, etc. So in order to understand what the organic reactions are, you have to understand first what are the different types of organic reactions, when and why some reactions occur and others don't, and all the aspect you have to cover it. Thank you for your patient hearing.